Welcome to this explainer. Today, we're going to peel back the layers on something incredibly fascinating, the world's most advanced AI art installation, the Google Dataland AI Museum. On the surface, it looks like pure magic, but we're going to reveal the absolutely staggering technological and financial engines running right beneath it. It's a foundation that is literally reshaping everything, from your web browser all the way down to the physical infrastructure of the internet. Okay, let's dive right in.
So let's start at that beautiful surface with Dataland itself. Co-founded by media artist Refik Anadol out in Los Angeles, this museum basically acts as a breathtaking sensory interface for Google's most powerful AI models. You weren't just looking at pre-rendered video files looping on a screen here. The installation utilizes the large nature model and Google's Gemini to generate real-time, interactive art based entirely on what's happening in the room at that exact moment.
And we're talking about a massive 25,000 square foot space here. But honestly, you shouldn't even think of it as just an art gallery. It's much more accurate to think of it as a giant real-time output terminal for the multimodal software layer of 2026. The sheer intelligence required to generate these omni-sensory experiences on the fly, it demands an entirely new breed of software.
To really understand how Dataland generates reality on the fly like that, we have to look at the rapid-fire release of Google's newest multimodal tools. In just a matter of weeks, we saw the launch of Gemini Omni, which processes text, video, and audio all at the exact same time. We saw Gemini 3.5 Flash completely replace the traditional Google search experience, and we saw the general availability of some highly advanced image models under the admittedly pretty hilarious internal codename Nano Banana 2 and Pro. The speed of this evolution is just unprecedented.
And this technology fundamentally shifts how billions of people interact with information every single day. Think about it. For 25 years, we relied on the legacy search. You type a simple keyword into a little text box, and you get a list of blue links. But now, with the integration of Gemini 3.5 Flash, that iconic search box is a dynamic, multimodal conversational interface. You can feed it images, you can drop in PDFs, upload videos, or even attach your active Chrome tabs. We are no longer just searching for information, we're actively collaborating with an intelligent engine to process it.
But here's the thing, the software layer goes way beyond just answering our questions now. We have firmly entered the era of AI agents, where tools like Google Flow act autonomously on your behalf. Imagine this. You take a picture of an event flyer on your phone. That's it. Gemini reads that image, seamlessly opens the Expedia app in the background, fully prepares a custom travel itinerary based on the event dates and location, and simply presents you with a one-tap booking button. The AI did all the heavy lifting, you just approve the final step. It's wild.
And that autonomous capability scales up for incredibly complex tasks too. Consider this number, 29. That is the number of different web sources a new deep research agent loops through autonomously. It reads, it thinks, and it heads back out onto the web again and again. Without a single human intervention, it compiles extensive, fully cited executive reports, synthesizing data from dozens of sources into one clean document. It's completely redefining knowledge work as we know it.
And these agents definitely aren't just summarizing text or booking flights. Multi-agent swarms, like Google DeepMind's Alpha Evolve, are actually scaling across critical scientific fields. Autonomous code generation is already driving a 30% reduction in DNA sequencing errors in genomics. In quantum physics, it's achieving a 10x lower error rate in quantum circuits. And incredibly, in AI infrastructure, the agents are actually optimizing the designs for the next generation of TPU chips. The AI is literally designing the hardware that will run the next generation of AI. Let that sink in.
So, we've seen the software, we've seen the agents, but this brings us to a really critical question. As incredible as Dataland and these digital agents are, the most disruptive shift right now isn't happening on our screens. It's happening on our streets and our factory floors. What actually happens when AI gets a body?
Well, the market is answering that exact question with massive, massive capital. $1.2 billion. That is the staggering Series D funding raised by a UK autonomous vehicle company called Wave. Their goal? To integrate embodied AI into commercial driverless robotaxis globally. And they definitely aren't doing this in a vacuum. They're backed by a massive partnership with Uber and the automaker Stellantis.
Let's look at how this physical embodiment is actually taking shape out in the real world. Waymo recently acquired Apple's abandoned $220 million test ground down in Arizona specifically to validate their new robotaxis. To train these vehicles safely, they're using the Waymo World model powered by Genie 3 to generate hyper-realistic simulations of rare and dangerous driving scenarios. Meanwhile, Boston Dynamics is partnering with DeepMind to put the Gemini robotics model directly into their Spot robot dogs. This grants them advanced spatial reasoning and autonomous decision-making in super complex industrial environments. AI models are now making real-time, high-stakes decisions in physical space.
Now, naturally, as this deeply powerful technology permeates society and the physical world, it is generating some serious friction. The legal and geopolitical realities here are stark. The state of Florida has filed a lawsuit against OpenAI, claiming the technology lacks adequate parental oversight and harms minors. Over on the national security front, we've seen the historic conviction of a former Google engineer on 14 counts of economic espionage for stealing AI technology for China. And in the corporate sphere, a jury recently ruled that Elon Musk's lawsuit against OpenAI was barred by the statute of limitations. Across the board, societal and legal frameworks are scrambling to catch up to the code.
Which brings us to the very bottom of the iceberg. To sustain the beautiful real-time art of Dataland, to power millions of autonomous agents, and to run the brains of robot dogs and self-driving cars, it all requires a physical foundation of unprecedented scale. Alphabet recently announced a historic $84.75 billion equity raise. Let's break down where that astronomical sum is actually going. Alphabet is treating AI infrastructure as a permanent structural cost of operating at the frontier. They are pouring billions into simply expanding the physical footprint of their data centers. They're deploying next-generation custom silicon, specifically the new TPU-8i and TPU-8t chips, which are designed for fast agentic inference and massive model training. And crucially, they are heavily investing in advanced cooling systems to manage the extreme thermal output of these massive server clusters. They're building faster than competitors, and they are fully willing to dilute existing shareholders to fund it.
And Google isn't alone in this massive capital burn either. A recent SpaceX IPO filing revealed that xAI lost $2.4 billion in just the first quarter of 2026 alone. Why? Because they are renting a mind-boggling 300 megawatts of compute capacity from Anthropic for $1.25 billion per month. The entire industry is burning unbelievable amounts of capital and energy just to keep these models breathing. If anything, this proves the current wave of enterprise AI adoption is only in the early innings.
But there is a ceiling rapidly approaching here. Because classical computing simply cannot keep pace with the insatiable energy and performance demands of advanced AI, the foundational layer is already looking toward the next horizon, quantum computing. And to be clear, this isn't just a faster classical computer. It's a fundamentally different computational approach designed to solve entirely new classes of problems with far greater resource efficiency.
And major players are making their big moves right now. Look at IBM's roadmap. They recently secured a proposed $1 billion federal award to build a U.S. quantum wafer manufacturing foundry. Backing that up, IBM announced they will invest $10 billion in quantum R&D over the next 5 years. Their ultimate goal? To deliver quantum Starling by 2029, a system with 200 fault-tolerant logical qubits, capable of 100 million quantum operations. They are practically sprinting to build the hardware that will eventually unblock AI's physical limits.
So the next time you see a breathtaking, real-time AI generation, whether it's the beautiful, shifting sensory art of the Google Dataland Museum or an autonomous robot casually navigating a factory floor, remember what you are actually looking at. You are looking at the very tip of a multi-billion-dollar iceberg that is rapidly rewriting the physical and quantum foundations of our entire world. As classical data centers max out the global grid, will quantum infrastructure be the ultimate engine powering the AI of tomorrow? It's a fascinating question, and one we will undoubtedly be exploring very soon. Thanks for joining me on this explainer, and keep learning.